Bismillahirrahmanirrahim. Assalamualaikum to all students. Okay, our topic now is 5.5 higher order derivatives. Okay, for the previous topic you already learned on how to differentiate many types of functions. Okay, we have for example we have log function, exponential function, okay, and then you apply many rules, okay, to solve the equation, solve the function. So now, okay, for the higher order derivatives, okay, what does it mean by higher order? Okay, for the introduction part, okay, what you have to do, if you see this kind, okay, this symbol, okay, f prime x, meaning that, okay, this one usually, okay, we call it as first order derivatives. Okay, and then if we differentiate second time, okay, we have here double prime, okay, call it as second order derivatives. And then let's say we differentiate third times, okay, we call it as third order. And this one can go to f and x, meaning that this one you differentiate as ninth times. Okay, so these are, okay, the step or the method for the higher order derivatives. Okay, so meaning that you have to differentiate many times. Okay, let's say we have here to differentiate 4 times, you can write as 4 f for x. So meaning that this is fourth order derivatives. Okay. Okay, now we proceed example 1. Find the derivatives of all orders of the polynomial functions. All orders meaning that you have to differentiate many times. Okay, when you have to stop when you get 0. Okay, so now we have your function f(x) equal to x power 5 minus 3 x power 4 plus 4x power 3 minus 2x squared plus x minus 8. Okay, first order, okay, differentiate as usual, what like you always do. Okay, so now we have here 5x power 4. Okay, we bring 5 to the front of x and then the power will be minus 1 minus, okay, we have here 12x power 3 plus 12x power 2. We have here 4x cubed minus, okay, 4x we differentiate 2x squared plus 1, okay, because of we differentiate x minus 0. Okay, no need to write 0. Okay, differentiate second time. Alright, second time. So 4 multiply 5, we get here 20x power 3 minus 36x power 2 plus 24x minus 4. Okay, differentiate 1, we get 0. And we differentiate again for the third times. So now we get here 60x squared minus 72x plus 24. Okay, because of we differentiate negative 4, we get 0. Okay, differentiate okay, fourth order. So what we get is 120x minus 72. Okay, okay, 5 times f5. So differentiate this one 120. Okay, differentiate 120x, we got 120 and minus 0. So we stop here until we get the value of 120. Okay, because of if we differentiate 6 times, okay, differentiate 120, we get 0. Okay, so this is incorrect. Okay, so when you have to stop when you get the value of 120, okay, before 0. Okay, example 2, find the first and second derivatives of the function. Okay, now we have fx equal to negative 0.2x squared plus 0.3x plus 4. Okay, for the first and second order derivative, okay, this is the first order. Okay, we get here negative 0.4x plus 0.3. Okay, differentiate once again to find the second order, so we get here negative 0.4. Right, so that's all. Okay, this is how we solve. Okay, and the second one. Okay, now we have here example B, fx equal to x cubed over ln x. Okay, ln x, this one is actually log x base e. Okay, so now you have to apply quotient rule because of we have variable over variable. Okay, so the first step is remember the formula g f prime minus f g prime divided by g square. Okay, so now we put into okay, the first derivative. Okay, what we get is, okay, our g now is ln x. Okay, f prime we get 3x square minus x cube. Okay, because of f, and then g prime differentiate ln x. Okay, ln x is actually log x base e. So you have to do a line, and then we have to copy whatever in log, okay, x, and then ln e differentiate x, we get 1. Okay, and then divide. Okay, the formula we have g square, mean that ln x square. So now we simplify what we have here. Okay, ln e is equal to 1. Okay, x we can just cross. Okay, sorry, use other colors. So we can just okay, ln e equal to 1. X, okay, cross with x cube, we got now x square. Right, so now we rewrite, okay, log x 3x square minus x square divided by ln x square. Okay, this is the answer for the first order. Okay, first order derivative. Okay, for the second order you have to use the lattice one. So now we know that this is f and then this is g. You have to formula, okay, again the same formula, quotient rule. Alright, so the answer, the solution for the second order, okay, g we have ln x square. Okay, g f prime. Okay, now we have here product rule. Okay, you have to apply product rule this part. And then now we have here our f is, this is f, and then this is g. Okay, so we put into the bracket. The formula is f g prime. Okay, ln x. Okay, wait, before that, okay, if you forgot, okay, product rule. Okay, the formula is f g prime plus g f prime. Okay, okay, we put into the formula. So now we have f ln x, and then g, okay, differentiate g, we get here 6x. Okay, plus our g now is 3x square. Okay, differentiate ln x. Okay, remember when we differentiate ln x, basically you can see from here, if we differentiate ln x, we get here 1 over x because of ln e is equal to 1. So every time you differentiate ln x, okay, the value is 1 over x. Okay, this one actually can save your time. Okay, 1 over x. And now we have here minus x square. Okay, back to our okay, f1 now we have here. Now we already apply product rule. Okay, and then we have here okay, the product rule, and then don't forget about the x, minus x square. So you have to write minus 2x. Okay, now we have another bracket because of, okay, this one is actually the, okay, this is g, remember. Okay, this part is f prime. Okay, and then minus, okay, this one actually quotient rule, right? Okay, g f prime, our f now is ln x 3x square minus x. Alright, okay, this is g f prime, and then f, okay, g prime, differentiate this one, okay, ln x square. So what we get, okay, you have to apply chain rule. Okay, 2, copy all inside the bracket, and then the power become 1. Okay, differentiate ln x, we get here 1 over x. Okay, okay, divide. g square ln x power of 4. Okay, this is the answer. I hope you understand. Okay, quite complicated. Okay, where we have to apply quotient rule. Inside the quotient we have product rule. Okay, this one g f prime. This part f g prime. Okay, so I hope you understand. Okay, this is example 3. Okay, given square root 2y plus x equal to 10, find dy over dx plus d2y over dx2. So now we know that when we see this kind of symbol, so you have to find the second order derivatives. Okay, and then okay, they say we have here square root of 2y plus x equal to 10. You have to make y as a subject. So we bring x to the right hand side. So it will be 10 minus x. Okay, 2y equal to, okay, square root, there will be square. And then y equal to 10 minus x square divided by 2. Okay, so to find this one, you have to find dy dx first. So differentiate this. We now have chain rule. Okay, so this one you don't have to use quotient rule because of we have v over c. Okay, v over constant, so you have to apply chain rule. Okay, bring 2 to the front of the bracket, power minus 1, and then differentiate inside the bracket we have here negative 1 because of we differentiate negative x, and then divide by 2. Okay, 2 is a constant, just leave it there. So now we can just cancel out. So the answer is negative 10 minus x. So differentiate this, we get here we just expand. Okay, we get 1. Alright. Oh, sorry. So now we already differentiate this, right? So dy over dx is equal to negative 10 plus x. Okay, now we find the second order. Okay, differentiate this one, we get 1. Okay, the question asks you to find dy over dx plus d2y dx. Okay, this one, when we substitute all the info into the question, so we get here negative 10 plus x, and then we have to add 1. Okay, because of d2y over dx2 equal to plus 1. So the answer is x minus 9. Okay, this is the final answer. Right, so I hope you understand.